Hello, hello everyone. So today's web series session, we have Vijay Solanki who will be taking us through understanding of Webpack. And this is the part one of a complete session. There are even more parts in this session. And we divided this session into different parts considering beginners approach and then mid-level approach where people can actually have some experience in hands-on and then later on more advanced topics. So today's session is more of about understanding of Webpack, why the Webpack was invented, how the Webpack works. And for further discussion, I would like to thank you, Vijay, for participating in this session, doing all the research, coming up with presentation, and agreeing to have work as a speaker for today's session. And also thanks for all the team members who have joined for the session right now. Okay, so I'll hand over this to you, Vijay, so you can start.
Oh, okay. Thanks, Vinay. Hello, everyone. Thank you everyone for joining this session. I'm Vijay Solanki. I've been working as a front-end developer at Yapsody, India for over a year now, and it's been a great time here. Uh, a little bit of a background about me. I'm from a non-IT background. Uh, I always had interest in how software works, so I taught myself how to code, and then started working as a freelancer for a time. And it's not real. Well, then I joined the Yapsody for
That's
it.
wonderful to know, Vijay. So like you especially being not from the IT background and actually learning all those things by yourself. That's really amazing and good to know about that.
Yeah, thank you. Okay, so today's session is about Webpack. Today I will be sharing my knowledge about Webpack on what I've known, what I learned as a front-end developer. So, okay, let's start. So, what will you learn in this session? The goal of this session is to understand the concept behind the Webpack, not the Webpack APIs, like how to optimize and performance. That's not what we'll be looking at. We'll be looking at the core principle and of Webpack, like why and how and what about the Webpack. Uh, why do we need a tool like Webpack, which is a module bundler, and what is tree checking and code splitting. We'll also look at the basic configuration of Webpack. Let's start. So what is a Webpack? So Webpack is a module bundler, uh, but it is a strange word. Like what is a module and what is a bundler and what is the module bundler? So before even looking at what a module bundler is, let's first understand why do we even need one. So how do we use a JavaScript in the browser? Like there are only two ways in the JavaScript in the two ways we can use a JavaScript in the browser. First, we will have a script tag and we will write our JavaScript between the script tags. And then there is we can add a script tag to a file like this. So like, what's the problem in this approach and why aren't we using this instead of Webpack? So what's the problem? The problem is the more your project get complicated, the more not just the JavaScript, but more like CSS and your assets like images, fonts, etc. You have to add manually, and with a big project, it's quite a mess up. Like you can have a end up with like thousands of script tags. So that is not a good approach. Basically, it doesn't scale in a large projects, and browser have to load too many scripts. So like each browser have these bottlenecks where it can only process concurrent request, like which is related to HTTP1 and HTTP2. We are currently using HTTP2. So like the problem isn't about we are loading 100 files. The problem begins when you load like thousand scripts. Like if you have thousands of component, you will be loading thousands of script. मतलब, CSS, JavaScript, all that. So breaking an app into thousand file and loading them in a browser is not an option. It's a performance issue. So why don't we just write a big one JS file, right? Why don't we just put everything in one file and then load it? Which is because we can't do that because it's unmaintainable. There can be a naming collision, like not in a thousand file, but you can have a naming collision in a 200 line files. There is a readability problem, like when you go through when you have a bug and you have to read through a code, which is impossible if you have a thousand and thousands of lines of code in a single file. So what's the solution? Wrap everything in a IFI. But what is a IFI? So like let's see an example of IFI. Like if we have a function, whatever I write inside this function or whatever variable I declare, if we run this function, we'll get the foo. But if I try to access this variable outside of this function, we'll get an error. So what if we put all of our code, like not all of our code, but uh, imagine you have one file, and what if we put every file in a function and then execute that file? So there will be no naming collision. Like, but you have to call the function directly with the name. So what's with that? So if you don't have a call, you don't have to call a function. What you can do is grab this braces and call this. Now you don't have to give a name or anything, or you have to call this function exclusively. And we have a log function. So what we can do is we can put every file inside IFI, and then we will not be having this naming collision. Like this can act as your file one. You can have a multiple IFIs, which will be working for multiple files, and there will be no naming collision. Okay. So why is this working? If you are thinking, then whenever you add braces, sorry, parentheses around a function, JavaScript read it as a executable. So it will execute this, and then you can call this function. So like whatever inside a function is scoped inside a function, so you cannot leak any variable or any function declared inside a function. So this is a if is immediately invoked function expression. So like this is an expression, right? So if we wrap every file in a if, then naming collision problem is solved. So like this idea of wrapping every file in if and concatenating that like in a big single file, this whole idea led to a creation of tools like task runner, like gulp and grunt and broccoli, I guess. No, broccoli is a module bundler, like gulp and a grunt. So our naming collision problem is solved, but there's still a problem. So when we concatenate the script inside if we, what should be the order of the concatenation? Like, what if you are running some DOM and manipulation with jQuery, but jQuery isn't loaded? You will get an error, right? So we have also have to think of that order of order of the script. And what about the unused file? Like, if you have thousands of file, we cannot imagine maintaining that thousand file, and we don't even know if you are using one or not. Like birth of a Node.js around this era, like 2012, I guess, 11 and 12. So Node.js came with this module system called CommonJS, where which provide an easy way to uh, use use a sorry, share a common share a function and share a functions in your code. So common JSON, the common JS module system solve many problems. Like we don't have to remember the scope of the variable. Each file act as if sorry, each file each variable declared inside a file cannot be leaked outside of the file. We don't have to manually wrap in the if every file for every file. And the syntax was very easy. Like if you want to require something or you want to use from another file, you just use the require function. And to export the thing, you can just module dot export. And there's still a problem. Like around this, when Common JSON came out, everyone wanted to use a Common JSON for a browser. But how can we use a node in a browser? Like Common JS not, is not supported in the browser. So we have this problem. Like how can we run a module system inside a browser? Solution. Module bundler came to the rescue. The module means like the module act as a boundary between your file where your variable and your code cannot leak outside of the file. But even with the running CommonJS in a browser environment, there was still a problem with like running CommonJS with a module bundler. There's still a problem in that. Like CommonJS is too dynamic, no code splitting. Like you cannot do async import, and there's a problem with tree shaking. So like, let's say what is a dynamic. What do we mean when we say the common JS is too dynamic?
Hey, Vijay, just as an example, can you explain what is tree shaking? Like, that term I saw there, and for other people, like, who are attending, maybe uh, you can let us know, like, what exactly is a tree shaking?
Yeah, like I was just going to
Okay, definitely.
like let us see what are why the common JS is too dynamic and why tree shaking. What is tree shaking? Why doesn't it work with common JS? Like let's just say you can do something like this, and you can use a require function. And this is how the common JS syntax look, right? Like you can require from a file which is, and you can use this function, which is exported as a default. But we can also do something like this. Like if I have a function, and if I call a function, mm, what if I pass the require into this? Forget this. Because this require function is available globally in a Node.js environment, I can pass as an argument, like in a manipulation function, and it will receive as required. And then can I do the same thing? Like I can pass another, there is another function and I can pass that argument to another function. Like this is what we call as a dynamic, like nothing is stopping us from use manipulating the require function. Or so why it doesn't support the tree shaking? So like for tree shaking, we need something called static analysis. Like what is a static analysis? So imagine if we have a function. So if we have a function like this, like one, it logs one, there's a variable. Okay, sorry. I need another file. I'll just add one file. I'll add two functions. B, B. sorry. Okay. So like I created a file called utils, and we have a two method inside this, sorry, functions, sum and a multiply, and we exported sum and multiply using a common JS module.export. And then uh, we can require something from utils.js using a require function, and we required a sum function, right? And here in sum we are using it. But because require is so dynamic, like before we saw example of passing a require through functions arguments, like how do we keep track of like how require is used? So like for tree shaking to work, we need something static, like okay, so for one more example, like for this is, yeah, this is an object, right? For here, and I can add some condition like when to export or not, some this multiply function, and this will based on the some uh, some conditions. Let's say this exporting this function is based on a condition, and because this object, it is not statically analyzable. Sorry. uh, I
Yeah.
was unable to unmute myself.
Okay. Yeah. Go ahead.
So like tree shaking, the concept of tree shaking is that if we have a utils file and we have a thousands of utilities inside that is a functions, and we are exporting every one of them, and we are using only a multiply function out of all those export. Then inside a bundle, when like here we can see we have only required some some method from a utils.js. So the when we bundle this code, it shouldn't include everything else that is exported from utils.js.
Right. So basically, you're talking about the dead code which is present in the application when you import all these bundles. So this is
So
just a removal of all that dead
uh,
code.
this is tree shaking is little bit different than dead code elimination, because like what the module bundlers do is like they look at what you have what are the unused export from the file. Like they don't look at the input that you were required. They look at like uh, this is the file which this is the utils file which are using functions from. So like
Okay.
the bundler will look at like this all these exported functions,
Got it.
and what will decide is like if any one of this function is using like it will check statically that if
Hmm.
any of this method is used inside anywhere in the code, then it will include in the bundler or it will eject. So it doesn't remove the code. What we'll do is what module bundle do is like they will go and mark this function like multiply. We are not using multiply, so like it will add a comment for a part of bundler which is called like dead code elimination. It will add a comment like remove this, it is not used, not the actual this comment but something like this. So like the
Got it. So
part of tree
basically,
shaking.
bundler will basically automatically figure out like if certain functions are not used, it will mark those functions as
Yeah,
not used.
yeah,
So
like
okay.
the
So does
part
it
of
like
bundler.
keeping the size of the final delivery small because like certain functions are not included?
Sorry, I didn't get
So like if you're like if the code is present in your project, for example, and
Yeah,
you don't use certain part of that code, like
yeah.
certain functions that are not used. So
Hmm.
does it mean that like those functions which are not used, those will not actually be available in the output files that are compiled?
Yeah, it will not available. Those functions which are not used, which will it will be removed from the final
Okay.
bundle.
Okay, got it. So that's what the tree shaking is, and that's where the bundler actually helps you to automatically do that.
Yeah, the part of tracing is just basically like mark these functions which are not used. Like don't
Got it.
remove them, do nothing. Just mark this function as not used, and then that code elimination will come and see like this function is not used. Like it will look at the comment actually and
Got
see
it.
like yeah, this function is not used, and it will remove this function from a final bundle.
Yeah, which I think is the problem that many people face when the project becomes larger and larger, and you have like a lot of code which is written in the past that the new version of code is added, but the code is not actually removed from the project. So I think it
Yeah.
helps later on, like when you actually reach that stage where you have like a very huge project which is under maintenance, and then you have like a lot of versions of different codes, I guess.
Oh yeah, it
Definitely helpful.
helps with that. Yeah,
Got it.
like, but the problem we are seeing with common JS is that it's too dynamic because it's not exporting, like it's exporting a object, and
Right.
object are highly dynamic. Like I can add a condition over here, like something. If this is a condition, then multiply or null. Like how a bundler going to know what this condition is at the
Okay, so that is the
runtime.
problem with common JS. Like, common JS won't be able to do this correctly.
Yeah, because it's too dynamic, and not just the module dot export part, but also like require function. Like you can pass the require function and level of inside a function and then require something. So like how does a
Got
module
it.
bundler will know like it
Got it.
is used inside this function?
Got it. Great. Great. Understood. Yep.
Okay, so like that was the tree shaking part, and what a dynamic or async import is, which is mostly related in the front end scenario. So like when you have a big websites, you have these different pages and you have these large libraries. You have these different pages. So like when user goes to your login pages, you don't want them to download your dashboard code, right?
Yeah.
So like you can make that work like if I go to certain route, download this code, or if I click on something, download this code. If I hover on something, download this code. This is what is known as a sync or a dynamic import. Like you can import at something at the runtime.
Okay. So it's more like a lazy loading in the
Yeah,
front end concept. Okay.
yeah.
Got it.
Okay. So common JS is too dynamic. Like we
Got it.
saw that, and so like people started creating their own module system because like AMD and AMD plus common JS, uh, but they were also really highly dynamic, which did not have a static analysis. like there was no single specification on how a module system should work. Like there was not a standard in JavaScript, like how a module system should work. Like there was only one common JS, and then everyone just started creating their own module system. Like
Got
we
it.
can look at AMD, like how its syntax was not very good,
Okay. So
was
basically,
completely.
like, everything was created on the basis of JavaScript, which is like a very much dynamic language in its own uh, functionality.
Yeah, yeah,
So,
yeah.
so
Mm,
like without static analysis, obviously, like, it's not possible to actually optimize the bundles because
yeah,
the language itself is dynamic in nature. So, yeah,
yeah. So like we can look at this AMD syntax and how, like we look at CommonJS syntax, and now let's look at the AMD syntax. Sorry, AMD module system syntax. So like you have to define that there is a define function, and then you pass array, like how we do a require this and require that. So like here we can do if you want to require jQuery, then jQuery or dispatch or something services, and then we pass a function inside it, which function has the arguments from all of this. Like all of these are passed inside this function, and then function is called, and you can do stuff inside it. Like we can see like how this is a dynamic. Like looking at this, we know
yeah,
like
yeah. It's very much like, by just by looking at the code, you itself, like, we come to know, like, that developers are going to hate writing such code.
yeah,
Yeah.
and yeah, and
So even
still
if it
people
solves
write
some
it.
problem in a long term, it's going to be very difficult to manage this code.
Yeah, so like the idea behind asynchronous, I forgot the full form of the AMD, but the why AMD was created because the common JS didn't support the async import,
Yeah, it's
and people
asynchronous
wanted,
module definition. Yep.
yeah.
Yeah.
So like, and people wanted to asynchronously import anything. So like, it is not possible for it is not possible in AMD to tree shake, but it is possible if you can have async import. Sorry, you
Got it.
can have async import in AMD,
Got it.
but
So this all effort is to just make sure that we don't download and spend users valuable bandwidth downloading a part of code which is not going to be used, which is never going to be used. So this is
yeah,
like we're still fighting about that, and this is where I think the model bundler that we are looking about, Webpack, comes into picture.
yeah, exactly. But
Yes.
uh, even if we have a module bundler, uh, how do we tackle this problem of common JS? Like Webpack is built on a Node.js, right? So
Yes.
it is using inside common JS. It Webpack is inside it using common JS. Not just the Webpack, but if you look at the tools like ESLint, Prettier, and Babel, this all use the Node, and this all tool uses the common JS syntax,
Hmm.
because no one is going to use the AMD, I guess. It's just not very fun to work with.
Got it.
So like there is no standard for in JavaScript for a module system specification. So like everyone just creating their own, but there is a solution. Uh, After like 10 to 15 years of working, the ECMAScript modules comes out, which is a module specification for JavaScript, which is built inside a browser. So like this tackles some major problems. Like ECMAScript modules is what is the future. So like this is the syntax for ESM, ECMAScript module. Like you can import certain things from the file. You can export. You can export them. The syntax is easier. So like there is a better static analysis. But why a better? Because like we saw, over here. Uh, like we require something, and this you see is destructuring, right? Because module.export, what we did here, it was exporting object, which is a dynamic itself. But in what we see here is it's not a destructuring. It's a part of ESM. It look like destructuring, but it's not. And we cannot it is not dynamic because it is built with the nature of with a with a keep in a mind of for static analysis.
Got it. So like when you say require, it is basically going to load the whole file, and after loading the whole file, it is just going to like use certain parts of it which you use in destructured way. Like, if you say, like, one thing, only one thing will be actually used, but anyway, it is going to import the whole file technically if you use require.
Yeah,
The
but
whole file
this
get
is
into memory, and
the
then you are only going to use some out of the whole thing. But if
yeah,
you
but
use
this is
import, I think it is only going to import that many. What do you say? Like the modules.
yeah, but importing the whole file is not a problem for node environment because mm, they are running on a server and there's no problem if we include a whole file or there isn't we don't even need a sync import or tree shaking in a node environment. Like there's no bundle, I guess. So like ESM provide a better static analysis through its syntax. Like there's also an encapsulation like what we got from IFI and CommonJS. It is also included in a ESM. It will not leak the your variable or function declared inside a file. The syntax is very convenient. Mm, some browsers supports it, but there's still a problem. Like some, so like what is the problem inside this? Like now we have a ESM. Like after 15 years, we have a ESM. So like we when we use node packages, we create this dependency, right? Like we have entry file, then we can import React or some other library, and that React is also importing some other libraries, and there are n level of dependencies inside of one file. So inside of one library. So like ESM dependency resolution, like what is dependency resolution? Like if you have a index.js and there is a and you import React and you also import a Lodash and you also import something from your uh, code, let's say dashboard, and dashboard also import something else. Like there is a dependency. You have to create, browser have to create this dependency graph before even it starts your website. They have to go through each and every dependency and import its code, and then it show you to the screen. But at a runtime, creating a dependency tree is very slow because imagine if you have to create a dependency tree at a runtime for thousands of files, which is not very ideal in a browser at a runtime. Like this is where a module bundler or let's say Webpack comes. So what a Webpack, it's, it was this slide. Yeah. So like what is a Webpack? So Webpack is a static module bundler. Like we see why static, because dynamic isn't helping a web environment for mod. So Webpack is a static module bundler for JavaScript application, and Webpack processes your applications like how it processes, like you provide it one file or one single entry and it goes through that single entry and look at each and every dependency of that file that is imported in that file, and then create this something known as dependency graph. And through that dependency graph, it generates a bundle, like a final bundler. So like okay, like before we were only talking about JavaScript as a module, but Webpack support, because of a Webpack, you can use anything as a module, not just a JavaScript, but your CSS, your PNG, even your font files. You can see over here like coffee scripts. In the coffee script, you can also input coffee script file, and Webpack will read it for you. So like there are some core concepts for a Webpack entry. So like let's just go through a concept and then we look at what that is. There's an entry, there's an output, there's a loader, there's a plugin. So like there are four main concepts in a Webpack. So like what is an entry? The entry is a like entry point of your application. Like you have a source file directory and there is a index.js, like where you import everything, where it is the start of your application. The output is like where you want to bundle this file, uh, like you can say a folder name, like whenever you run a web page, it will bundle your file in that certain folder. And that there is a loader. Let's see what a loader is. uh, we can okay. We are on a website, js.org website. Let's see what a bundler is, sorry, loader is. So let's look at the code. So here you can see the output, like you have output key and then you can specify a file name of your output file. And what a loader does is like, imagine you have this JSX file, like by default, uh, Webpack only support JavaScript, JSON, and maybe WebAssembly. I don't know. Some of the syntax, but what it will do with your JSX file or your CSS file or your font, like it doesn't understand CSS, it only understands the JavaScript. So like the idea of a loader is that you can have a loader. So like this is the syntax how we use a loader. Like we have a rule, sorry, we have a module, because the module is because the loader works on a particular per module. So like if you have by per module I mean per your JavaScript or CSS file. So like we can define a rule, like there is a test, that this test is a regex, and there is a use key where we can define the loader. So whenever this txt file come in in a webpack dependency graph, when we bundle it, will that file will go through this loader, and it will create a module out of it. So you can import this text file as an module. The next one is a plugin. So so we looked at where loader can be used. Like loader is used per module, like per file. Let's look at a plugin. So plugins have access to this Webpack APIs, like Webpack internal APIs. Like you can create a plugin where it will get into Webpack APIs and see and let's look at, so there is a step in Webpack compilation. It will get entry file, process through, process to loaders, uh, create dependency graph, and then come the optimization parts like unification, tree shaking stuff. So like what plugin help you do is there is a hook inside a Webpack where you can, whenever Webpack starts its bundle process through a plugin, you can step into this particular step and do your manipulation. Like before even yeah, it gets the entry file. Before it gets the entry file, you can do some stuff to that file. Like uh, you can you can add new imports, like, or you can add some extra stuff to the file, or you can hook into a process where Webpack go through load its file through a loaders, and you can do a stuff inside this using a web plugin. Any questions?
So if there are any questions about this, feel free to put it on chat. Uh, yeah, Vijay, is there a repository where people can find this, the sample code that you have used?
For this, like we have this one. I will put it.
Okay,
People can go and look into this. But
okay,
like even if you don't understand what a module or a plugin, sorry, what a loader or a plugin is, uh, there are some advanced stuff, and we can look into it some other time. Like it will be more easy to understand it practically than.
okay, cool. So I have just opened the meeting. So if anybody has a question, they can unmute themselves and ask question to Vijay. So I guess there are no more questions, Vijay.
Okay, so I have cloned this repo and we'll look at it. Uh, or Webpack example. Sorry, Webpack example. So I have cloned this repo and we have a package.json file. We have Webpack config, which is empty right now, and we have some files inside a source. So I have already run a Webpack install to install all dependencies. Sorry, npm install. I have sorry, we have a three script inside it, like for building, for development, and building for production. We will look why we have this modes uh, for development and production. So we have an index file. So sorry, uh, there are these dependencies, but you don't need all of them. So like to run a webpack, you only need these two web dependencies, but I have installed this just for later sessions. So one is a webpack, which includes a webpack compiler and a webpack CLI, which is which help you hook into webpack compiler using the CLI commands. CLI commands. So what we have done here is we have a dev script and a production script. And whenever we run a dev script, it runs Webpack dev in a development mode. And whenever we run a Webpack runs prod, it will run in a production mode.
Is there any difference? Like, why do you have to specify dev mode and production mode?
Yes, yes. For let's see an example for this. Inside a source, so by default, Webpack doesn't need any configuration, like what your wherever your source file is, or where do you want to output your files, output your bundle. So by default, whenever you run this Webpack command, so like why we have a Webpack and why we can't run this directly, because Webpack is not installed globally. And whenever we install these dependencies uh, inside a project using npm, it inside a node module said create this bin folder uh, which has a Webpack. So like it is not installed globally. Webpack is not installed globally, and npm help you run this something like it will go inside this bin folder and run a Webpack for us. So that is the reason why we have a Webpack. Uh, okay, okay, so like by default, Webpack doesn't need any configuration whatsoever. We have a source file in source index.js is a source file. We are importing some function from our utils file, and we look inside utils. That is, we are exporting two functions like sum, multi, and then we are creating an object. And also then we will look why we doing this, but we are for now we are only exporting two functions from a utils file. Okay, so we import sum and we console log this create variable, and we'll call this sum function. And if we run webpack run dev, which is for development environment, it will go through all the files, create a dependency, and bundle the output. So like we can see it processed main.js. sorry, it processed the entry file, which is index.js. And in index.js, there is also you, we have required util.js. So it processed two files and created this output bundle. So like by default, whenever you don't provide any configuration to Webpack, it output your bundle inside a disk and file called main.js. Okay, so like this is a bundle. But what if we delete it? Okay, so before I ran this Webpack run developer in development environment and we don't have any rules inside a webpack.config, then I'm telling this Webpack CLI to run a Webpack in a development mode. But what if I just run Webpack npm run Webpack, which will be without any modes, mm, and it will create a bundle. It will also warning that mode option has not been set and Webpack will fall back to production. So if you don't provide any mode to Webpack, it will by default bundle your bundle your source as a production code. So we can see it has minified and it has also mangling something known as uh, mangling is a term where a bundler rename your variables to a single length, so they take as memory. Okay. So we ran a webpack npm run webpack, which is in a production mode by default. And if we ran npm run development mode, now we'll look at the bundle and how it is generated. So okay, we are inside a dist main.js, which is a bundle. We can see here that is this parenthesis over a function, like which is ify. And let's see where this ify end. Like if we look at here, we see this ify ends over here, and this is the call or argument invocation of that ify. If you can just close this. And this is the invocation of that ify. So we can see we are providing an object as an argument to that function. And what we have inside that is a key basically in a development. The reason why you can look at this code and somewhat manner or understand it because it's in a development mode, and we looked at what it looks like in a production mode. So like we are we looked over here. This is an ify. You can do some stuff over here. And this, okay, this is what this whole file is. It's just a single ify, right? And it takes a function. Sorry, there is a function which take something, some argument as modules. And we look what that is. Let's just see what we are passing inside a function, which is this. We are calling this function with an object. An object has these keys, which is which is a path, which is a path to our file, which is a path to our files inside a source directory. So like our entry file by default was source.index.js. So it will create a key as a source index.js, and inside a key we can see that there is a function like this. We will not look at this for now. And this is the it is using eval for a development environment. So like we can see our index.js code inside this. Like we have a const, greet, hello, and console log and object. So it is over here. It is requiring a sum function and calling that with one or two. Uh, this code is what represent our index.js, like console.log greet. So, yeah, we can see our create and console.log. And there is also a key called utils.js, which is from our source utils.js. And if you look at over here, we can see we are exporting um, some some function, and we are also exporting multiply function. So from here, okay. And if you look at this is what we are doing, and we can see this code inside our output file. So now we looked at like Webpack output if as a bundle, and we looked at what argument if is called with, which is an object which will include our files and code inside them. And now we go inside this function, which takes module as an argument, and we can see it is declaring a variable called install module, and it is also declaring a variable, sorry, a function as a Webpack require. So because a browser doesn't support CommonJS require function, Webpack has to create their own. So like this is the require function or implementation of a require function, which will be used in the browser to load module. So Webpack is declaring its own Webpack require function. Some stuff, there are some stuff adding to the function. And if we look at like nothing is being called, we are just declaring everything. And if we look at the end of the file, right before where it is called, we are returning a Webpack require. So like we are calling this Webpack require function, which we saw here over here. We are we are calling this require function, and we are giving a module ID, which will be our path to the part to our entry, because whenever this one if we will run first, it will look at our first we will have to look at our index.js, which is our entry file, and import all the modules which are necessary. So Webpack require function, we pass an argument. Yeah, this is basically like they are setting a key to this function as a source, I guess. I don't know what else is, but this is not used anywhere. And so like we are declaring a key as this, and this value will be used inside this function. If we look at it, it it require a module ID as an argument. over here in the code, like it's checking, like it's keep this modules inside, keep it cache for a module. Like if the some module is already required, you don't have to go through a dependency tree and require it again. It will keep every module it required previously inside this cache. We can see like it is checking if the module id exists inside the install folder, sorry, install module, which is a cache. Then it will return that module exports, or else it will create a new module. It will create a new module and add it to the cache. So like we see, we are creating a new module as a var variable, and at the same time um, we are also keeping it inside our cache, which is over here. And this is what our module is. Like we have id for a module, uh, this don't know, and there is export object which will represent what our module exports. So like this is the module, and so here we can see it is executing the module function. Like this is the we pass the object over here uh, as an argument, this object which has a key of index, and over here we are requiring that we are using that object, and we are using module id, which is our source key, uh, and calling. So what it will do is this module, if we look at this object, it will look at this key at the start and run this function, like because we are requiring this key. Yeah. So this returns in function which are defined down, and we will call it with this module dot export view mod. Will pass it a module and a webpack require function, because a module can require another modules. So recursively we are passing a module require function, so it can be used inside it. And there's a flag like this module is loaded, uh, and we return the module dot export. Like when we call this function, you can see over here, it will run this eval, and there is webpack export, and everything that we are exported from index.js, it will be inside this, which is not, we are not we are not exporting anything inside of index.js, so there will be nothing. Then there's a require function which will be used because we are requiring utils, we are requiring a sum function from utils. So basically it will go through and recursively to every file and require every module inside it when we run this. So if we run this code, oh, sorry, node this dot name, we will see our console log over here, which is hello and some of the output.
Awesome.
So like this is a bit complicated to go through, but
Understood. But like, when it comes to actual development, like nobody actually needs to go into the distribution file and actually check how it works.
Yeah, but just to give you
Yes.
idea
Yeah.
how it
Yeah.
go through.
Yeah. That's
Like,
great. That's great. Yep. Always good to know, like if somebody wants to check out under the hood, like how the system works.
yeah,
Yeah.
uh,
Yeah. Cool.
like we can see here, like our browser doesn't support require common JS required function. That is the reason why Webpack has to create its own. So if we see in an index file, we are importing a ESM module, which is a ECMAScript module. And if we look and inside our main.js, which are bundle, there's no, it will be required as a common JS because under the hood, Webpack convert your ESM exports or in ESM imports to common JS. So it can be run through its own required functions. So, okay. Uh, okay, so let's see your production bundle. Like we see, like
Hey,
we are,
Vijay, just to like stop you there, we are nearing our the timeline for the session. So just a
okay,
reminder.
okay. Uh, how much time is remaining?
We have already crossed it. So,
Oh, like give
okay,
me 5 minutes.
sure.
Just 5 minutes. Like we look when we run our bundle when we create a bundle in development, it include all of our file. Like it doesn't minify anything, it doesn't reshake or anything. Like we can see this is our utils file object, and we are having this whole file inside over here. Like we are not even using a multiply function inside our index.js, but it is still inside our bundle. Sorry. uh, So like there is no tree shaking whatsoever inside this. And if we run the same thing inside a prod, in a production build, okay, so like now our bundle is minified, and this is also an if, just a different syntax, like there is an exclamation mark, but we see where this end function end, and we are calling this function over here. Like if we look over here, okay, I can't see anything. So like leave it there. But I can see where, but the multiplication is not inside a bundle because it is excluded from the build because it is not used anywhere because and we are only requiring some function. Also, if we look at a bundle size, like uh, when we run for production, it is 976 bytes, and if we develop for developer environment, it will be of 4.6 KB, sorry 4.7 KB. So lots and minified.
That's a huge improvement when you run it in production.
Yeah.
Cool.
So any questions
No, Vijay,
whatsoever?
you can proceed, Vijay. Like if they have questions, my chat is open, so I'll let you know.
Okay. Uh, so okay. there's nothing remaining, I guess. So we looked at why we need a module system and a module bundler. We also looked at the problem with CommonJS module system and how ES module enables static analyzing, which help with tree shaking because we cannot tree shake with CommonJS module system because it's dynamic nature. We looked at the basic configuration, not the configuration, but like what is build and etc. things, like how we can use Webpack without a config file. Uh, and we also looked at how Webpack create a dependency graph and how it bundles. Yeah, thank you everyone for sticking it to the end.
Yeah. Uh, all right. So can you just refresh the page? There is a feedback URL which is present. If you just refresh the presentation link, Vijay. Yeah.
Okay.
Yeah. So thanks again. Thank you, Vijay, sir, very much for taking us through understanding Webpack and how the Webpack works. And like it was a bit a longer session, but definitely was very much knowledgeable, very much helpful in understanding how the Webpack works. And we really went into detail there. Uh, and thank you for all the participants. And there is one task pending right now for all the participants who are currently present. Please use your phones, scan the barcode, scan the QR code that is in front of you, and please provide feedback for the event. And it really helps. And make sure your feedback is valuable. We appreciate all the participants as well as their feedback. Uh, we will keep this slide up for some time here. And meanwhile, if there are any questions, do ask us on the chat and please provide feedback meanwhile. Yeah, Vijay. That tree shaking thing is very interesting. Like the word suggests like a tree shaking when you shake the tree, dead leaves fall apart and fall down. So that is exactly what tree shaking is in terms of coding. So like when you shake the
Yeah.
tree,
So
the dead code kind of trickles down and gets out of your production environment.
yeah. So
Interesting
like
name choices there. Yeah.
yeah. So like tree shaking was introduced first in a roll up. So like I forgot to
Just keep the
mention, but that
presentation running there
sorry,
for the
sorry.
people. We can
Yeah,
discuss that. Yeah.
yeah, yeah. So like I forgot to mention, but Webpack is not the only bundler available for JavaScript environment. There are many others. Like there is a rollup JS, which introduced the term or a technique tree shaking as a first, and then Webpack another bundler took from it. There's also a Snowpack, which is we support, which is a very fast as compared to any other bundler for a production or for a development. Like there are many bundlers, like but the
Got it.
rollup and the Webpack are most out there.
Got it. So guys, again, like just to remind, we still have questions open. If you have any questions, do let us know and please provide feedback. Your feedback is very valuable. Thank you, everyone.